This one is C5H7O3Br, and it has two double bond equivalents. We have a CH2 and a CH2, so that's two CH2 groups, and we have a CH3 group over here. What's left over? We've got two C's, three O's, a bromine, and two double bond equivalents. I think what I would be inclined to do is choose two C double bond O's, and that leaves us now with an O and a Br. That would be an O, and this would be the Br. So these should be all the pieces. We can put them together now, and what we can see is that we have a CH3 here, and it's got three peaks, so that CH3 must be next to a CH2. So I'm going to go ahead and drag a CH2 down there next to it. You can also notice we have a CH2 that's got four peaks, which means it's next to a CH3. Now further, that tells me that this CH2 cannot be connected to both of these. If this CH2 was connected to both the CH3 and the CH2, it would consist of 6 peaks because it would have 5 adjacent hydrogens. So I know that the CH2 must be apart from the other CH2 that we see here. Now I can try and get some other clues as to where things are connected, and we can look at the CH2 here and where it is in the spectrum. You can see it's around 3.6 ppm. And that's kind of typical of a CH in the Br range rather than a CH connected to oxygen. Typically CH is connected to those are at around 4 ppm, although in this instance, it is kind of close, so that's not really a definitive ruling on exactly where it might be connected, but I'm inclined to put the bromine next to the CH2 for that reason. Then we can go ahead and put in where the rest of these things go, and I think that the C double bond O would go here, and this C double bond O would go here, and the O would go over here. Now you might be wondering, well, why does the why do we do it in this order? Why not switch these around and put the O over here, for example? Well, the problem we'd have with this is that this CH2 then would be between an O and a Br, and I would say that because we know that CH2 is connected to O's are around 4, and the one's connected to Br around 3.6, if it's connected to both, it's going to be higher than both of those, probably more in the 5 range. So the CH2 is not in the 5 range, so I would say that the O can't be next to the CH2. The other thing I know is that the O can't be next to the CH2 over here because this CH2 is between 2 and 2.5 ppm. And that's more indicative of a CH2 directly connected to a C double bond O, especially if we look at the correlation chart. CH is connected to C double bond O's are in this range here, typically 2 to 2.5. So really, that just leaves us with this possibility of having the C double bond O here, the O here, and the CH2 over here.